Hi there, welcome back. In this video, I'm going to show you how to do 7 of the most common data analysis tasks in both Microsoft Excel and in Python. Hey, it's Claudia here from Edlitera, where we help you grow your data skills and your machine learning skills for the real world. Now, when I first discovered Python many years ago, I was mostly using Microsoft Excel to do data analysis. But soon the data got bigger, the analyses got more complex, the workflows got repetitive, and Excel became a lot less fun to work with. It actually started getting in the way. Now, if any of that sounds familiar, that means that you've probably struggled with Excel before in much the same way. At this point, you may be wondering if Python and the Pandas library really are all they're cracked up to be as an alternative to Excel for data analysis. In this video, I'm going to share with you the top 7 most common tasks in data analysis and how Excel compares to Python when doing each of them. And if you stick around until the end, I'm going to show you a couple of really neat things that you can do with Pandas using a single line of code. So hopefully you'll be able to decide for yourself if Python and Pandas are the right data analysis tools for you. If you're finding value in this video, please go ahead and give it a thumbs up. It really makes a huge difference, and it's great encouragement for me to keep making these videos. Now, without further ado, let's get into it. The top 7 most common things that you will probably find yourself doing over and over again are looking at and representing data, selecting data, sorting data, filtering data, subtracting some data from other data, merging data sets, and of course, pivoting data. Let's go ahead and jump into a Jupyter notebook and an Excel spreadsheet to see how we're going to do each of those things in each of those environments. Like I said earlier, the 7 most common tasks that you may find yourself doing when doing data analysis are things like looking at data and representing it in a way that you can eyeball it, selecting data, sorting it, filtering it, subtracting it from other data, merging data sets, and finally pivoting, so pivot tables. Let's take those things one by one and see how we would do them both in Microsoft Excel and also in Python using the Pandas library. All right, so I have here on the screen a data set that I downloaded from IMDb. It contains some movie data, and we have things like the movie title, the rank, genre, description, a bunch of columns in here. If we're talking about just looking at data, eyeballing it, and seeing it on a screen in a table, there's nothing simpler than Microsoft Excel. As soon as I open this file here, I can already see all of the data. It's neatly presented in columns and rows, so pretty self-explanatory, right? Now, in Python, seeing the data takes a little bit more elbow grease, but not a lot. Assuming that you've been following my YouTube videos until now, then you probably already know how to install Jupyter, how to install Python, how to get a Jupyter server running, and how to start a Jupyter notebook. If you're all set on all of those things, then you're welcome to continue following along with this video. But if any of those things sound weird or you don't know how to open a Jupyter notebook to follow along, then go ahead and check out those other videos, which I'm going to link in the description below, so that you can get up and running with Jupyter and Python. Now, once I have a Jupyter notebook open, in order to visualize a data set, so just to be able to eyeball it, I have to do a few things first. The first thing I need to do is import Pandas. Because this is tabular data that we're working with, Pandas is going to be the fastest and most efficient and really easiest way to view this data and to work with it. So I'm going to run this cell here, and I'm going to import Pandas and alias it as PD. This alias is not necessary, but it's just a nice shorthand. If you're going to reference the Pandas library itself often, then this is going to come in handy. It's going to save you some typing. Now that Pandas is imported, the next thing I need to run is this read_CSV method from the Pandas library. So I'm going to do that basically by using this alias and saying pd.read_CSV. And once I run this line of code, what's going to happen is that the data is going to be read into a Pandas data frame, which is a tabular data structure that basically looks exactly the way that table in Microsoft Excel looked that we looked at a few minutes ago. Now, this Pandas data frame is going to be stored in this variable called movies, which is what I'm assigning this to. Now, once I have this data frame inside movies, the next thing I want to do is get a preview of it. So I want to see the first 16 rows of data. And in order to do that, I'm going to use the head method on the movies data frame. So one thing to note here is that head applies to the data frame where the data is stored. In contrast, read_CSV is a Pandas module method, right? So basically this applies to the actual module in order to use it. So let's run this code, and here we are. What we're seeing here is just a preview. The outcome here looks a lot like what we saw in the Microsoft Excel file earlier, with a few important differences. The first difference that you're going to notice is the index. You see that the index is the very first column of figures here. It's not rank, so it doesn't have a name, it doesn't have a heading, but you can see it next to each and every row. Now, this index starts at 0. In Python, all indices start at 0, and this is no exception. So we start counting at 0, and you can see here that I'm going all the way to row 15. That's because I asked for the first 16 rows. In contrast, if we look at the Microsoft Excel sheet, you'll see that the index here starts at 1. So this probably will make a lot more intuitive sense for you. If you have been working in Excel for a long time, it makes sense to start counting at 1. We start counting at 1 in natural language, but Python always starts counting things at 0. Whenever you are using an index for any sort of data structure in Python, you're always going to start counting at 0. The second difference that you're going to notice in this data preview here is that it's just a preview. You can't do anything with it right now. Besides the fact that you can scroll through it and you can see it, right? So I can scroll all the way down, I can scroll to the right and see all the columns. I can't do anything else with it. I can't click inside here and change the data, or I can't select the column, or all the things that I can do in Microsoft Excel. So this is just so I can eyeball it. That's all there is. The next thing we may want to do when working with data is that we're probably going to want to select only a portion of the data, right? So let's say that I just want to select one column from this spreadsheet. If I want to select the Metascore column, all I have to do is click it. So I'm clicking on top here where it says column L. This little arrow appears and I'm going to click it, and there we go. The whole column is selected. Now, let's say that I want to select more than one column. Let's say that I want to select not just the Metascore column, but also the ratings column. After I selected the first column, what I'm going to do is hit the control key and click on the second column that I want to select. And that's it. It's done. It's there. I've selected 2 columns. Very easy. Going back into the Jupyter notebook, let's try to do that same thing again and select the Metascore column. To select the Metascore column from the movies data frame, all I have to do is pass the name of the column as a string into this selector here. So in order to select a column or a row or a group of columns or rows from a data frame, we will use square brackets to be able to access specific data within the data frame. In this case, all I have to pass is the name of the column, Metascore, run this line of code, and there we go. Now, one thing to note here is that Python is not actually showing me the entire column. It's just showing me 5 values from the beginning of the column and 5 values from the end. This is useful because it's telling me, look, indexing starts at 0, everything seems to be in order. We have 1,000 rows in this column, right? Index goes all the way to 999, and I get to eyeball some of the values as well. However, I also have this ellipsis here, which is telling me that I'm not seeing the full data. And that's fine. It would be, frankly, quite impractical for me to have to scroll through 1,000 rows here just so that I can eyeball the data one by one. There are better ways to explore the data inside a data frame than just to look at it directly, which is why Python is not wasting real estate here, making me scroll through 1,000 rows. Now, if I wanted to select more than one column in here, let's say that I want to select the title and the Metascore columns together, what I have to do is that instead of passing the single string that identifies the one column like I did earlier, I'm going to have to pass a list of strings, including all of the string column names that I want to return. So in this case, because I want the title and the Metascore column, I'm going to pass a list that contains these 2 strings. I'm going to run this. And there we go, same thing. Slightly more nicely formatted because we have 2 columns now, so it looks more like what we saw the preview of the entire data frame looked like earlier. But it's the same thing, basically. We have the 2 columns that we asked for, we have the index here, and we're good to go. Now, one thing that I want to point out here is the fact that things are starting to get a little trickier here. You can see that we're using 2 sets of square brackets. Now, this is a point where I see a lot of beginners who are just learning Python for the first time start to struggle because it's real easy to forget to close one bracket or to not even use it to begin with and to get a syntax error. And then you're going to be wondering what happened, why is this not working? Now, this is actually such a common mistake that I'm seeing that I went ahead and I recorded a separate video for each type of parenthesis, right? So in this particular case, there is a separate video that I recorded that you can find in the description below, which walks you through how to use square brackets in Python properly. And we are discussing this point in great detail as well. Strongly recommend you go and check that out there so you can avoid any sort of errors that may come out of the need to use square brackets. All right, the next most common thing that we may want to do when working with data is to sort it. Sorting is super useful when we want to see the data in a particular order, right? Let's say that we want to see a series of numbers in increasing order or in decreasing order, or perhaps we want to see a list of names in alphabetical order. Now, let's say that I want to sort this entire data set by the Metascore column. And let's say that I want to sort it ascending. The first thing that I need to do in Excel is to select the data, click Sort, select the column that I want to sort, in this case, Metascore. I'm going to want to sort on values and smallest to largest, which happens to be the default. Click OK, and voila. Now the entire dataset has been sorted by this Metascore column. Jumping back into Jupyter Notebook, let's do the same thing on the Pandas data frame that contains the same dataset. In order to sort the entire dataset by the Metascore column, what we're going to do is we're going to apply the sort values method onto the data frame movies. That's all there is to it. Now, to the sort values method, we're going to pass the column name that we want to sort by. So in this case, Metascore. Because I know that the default way that sort values sorts is ascending, I'm not going to have to specify that. So if I just run this line of code, what I get is basically the same data frame, but in ascending order. If we scroll back to the Metascore column, you can see that this goes ascending now. Another really common task when doing data analysis has to do with filtering data. Now back to this data set, let's say that I want to only select those movies that came out in 2016. How am I going to do that? I'm going to drop a filter on this spreadsheet. To drop a filter, I just have to click this filter icon, which is going to drop a little arrow on each column header. So this will allow me to put a filter on whichever column I want. I'm going to click on year. They're all selected. I'm going to deselect all of them. And I'm going to just select 2016. And that's it. Now I just have those movies showing which were made in 2016. Back in my Jupyter Notebook, how do I do the same thing using the movies data frame, which contains the same data set? To sort only those movies that came out in 2016, I'm going to need to build this filter explicitly in Python. So one nice thing, in my opinion, about Python is the fact that everything is explicit. You don't have to search through menus to find the option that you want. Instead, you simply type up the option that you want in an explicit fashion. So in our case, the filter that we want is that the column year must contain the value 2016. Now, this highlighted part here is exactly that. Basically, the year column inside movies equals 2016. We use equals equals because that in Python is the equality operator, whereas a single equal sign is the assignment operator. So the selected part is basically my filter. Now, how do I apply this filter to the actual data frame? The same way that I select a column from the data frame. Basically, you put the name of the data frame first, and then you follow it by open square brackets and closed square brackets. That's it. Easy peasy. So if I run this line of code, the outcome is basically the same that we saw in the Excel spreadsheet. And now I just have all of the movies that were released in 2016. Another common thing that you may find yourself doing when working with data is that you may want to subtract a value from another value within your data set. So let's say, for the sake of demonstration, that we want to subtract the rating column from the Metascore column. Now, to do that in Microsoft Excel, what we need to do is first create a new column where we're going to store that result. So in this case, I'm going to call it difference. Now, to compute that difference, all I have to do is start typing the formula, right? Equal sign. Metascore is the column that I want to subtract from, minus rating, and that's my difference for the first movie. Now, to repeat this operation for each and every row within this dataset, all I have to do is double click on this corner and Excel will automatically do this operation for each and every row in my dataset. So there you have it. That's how you compute subtracting one column in this dataset from another column. Back in my Jupyter Notebook, let's try to do the same thing using Pandas. To compute this difference in Pandas, I'm going to basically do the exact same operation that I did in Excel, except, like I said earlier, explicitly. So I'm going to first create the column that I want the difference to go into. So in this case, it's quality difference. To create the column in a Pandas data frame, you simply come up with a name for the column that is necessarily unique from all the other names. This is very important because otherwise you're going to override whatever column you name in here. But in this case, I don't have this column inside the data frame. So quality difference doesn't exist. I'm going to create it. And I create it by just passing this name between the square brackets next to the data frame, right? So exact same procedure that we've used until now. So now that I've created this column, to it, I'm going to assign this difference. The difference is literally between the column Metascore and the column rating. So after running this, you'll see that nothing happens. The reason why nothing happens is because the difference was computed and it was put inside the data frame inside this new column that we created here called quality difference. Now let's verify that we actually have this column in there and it contains the right results. So to do that, let's look at the head of the movie's data frame. And sure enough, there's a quality difference column that was added here, and it contains the difference between Metascore and rating. All right, let's move on to the next thing that we may want to do when working with data. Another really common task that you will encounter while doing data analysis is the need to merge two data sets. So let's say that you have two spreadsheets, each of which contains some part of the data that you want to work with, and you want to bring all of that data onto one spreadsheet. So basically merge the two data sets. To illustrate this in Excel, I've made another spreadsheet that you can see here called reader_scores. It's another spreadsheet that contains the title of some movies along with a reader score metric, which you can think of a score that readers assigned to, for example, the screenplay while reading it. You can think of the reader score number as a value that readers of the screenplay of a particular movie assigned to it, for example. Now, let's say that I want to bring this reader score column to my original IMDb movie data set. In order to bring this column, I'm going to have to do a VLOOKUP to join these two data sets. So to do this, I'm first going to create the column header here, and I'm going to call it reader score. And in this cell, I'm going to type my VLOOKUP formula. So once you start typing the VLOOKUP formula, Excel already starts showing you the things that you need to put in it. Now, VLOOKUP is a fairly advanced formula in Excel. It's not something that beginners are going to play around with much. It's something that you can get wrong fairly easily, so it takes a little bit of getting used to. It has a pretty steep learning curve once you get started, but it's fairly straightforward to master it. So if you just practice with it a few times, I have no doubt that you'll be able to have it down pat. The first thing I need to enter here is the lookup value. Now, the lookup value in my case is going to be the title of the movie. So the thing that I want to look up in this new data set that I want to merge with this data set is that I want to look up this title of the movie inside this new data set. So I'm going to select this first. The lookup value is going to be B2. Now, B2 is only the lookup value for this first cell. So literally the cell that we are writing this VLOOKUP formula in. Now, once I'm done writing this formula, I'm actually going to want to propagate it into the rest of the cells inside this column so as to bring back all of the values that are associated with those movie titles. So in order to do that, I'm going to want to freeze this value using a $sign in front of it so that I can easily propagate it throughout the column. Now, the table array is basically the table in which I want to search for those values that I want to bring back. So in my case, it's going to be this new spreadsheet. And here I'm going to select the entire table. So basically both of these columns, both columns A and B, are going to be the table array that I'm searching in. The next part of the formula has to do with the column index number, col index num. What this next term refers to is basically the index of the column in the new spreadsheet that I want to bring back into this current spreadsheet. So going back to this spreadsheet, the column that I want to bring back is column B. The index of that column is index 2. So the reason why it's index 2 is because in Microsoft Excel, we start counting at 1. So column A has index 1 and column B has index 2. We're going to put that in here because we want the second column in that array. So we're going to put that here too. We have one final term that we need to add to this VLOOKUP in order to complete this merge. So the next thing I want to specify here is whether I want an exact match or a fuzzy match. It's possible to do a fuzzy match, especially on something like titles, right? Because you may want to match different spellings of the same title to be the same thing, but that's not what we want in this case. So in this case, I'm going to assume that the titles are spelled correctly, and I'm just going to say that I want an exact match. So in order to do that, I'm going to put the value 0 here for false. I'm going to close this parenthesis and hit enter. And the result here is the score 4. Why? Well, the first title here is 9 lives, and that also happens to be the first title in the second data set, and the reader score for that is 4. So the result is correct. Now, what I want to do next is that I want to propagate this reader score throughout the rest of the column so that I can populate the reader score for all of the movie titles. So to do that, I hover this plus sign over the corner of the cell, double click on it, and there we go. We have all of our reader scores brought back, and we have effectively merged the two data sets because now we have the information in this second data set also in our original. Now back to our Jupyter notebook, we're going to go ahead and merge these two data sets again in our notebook using Python and Pandas. Now, if your head is spinning even just a little bit after that VLOOKUP that we did earlier, then this is the part where you're hopefully going to find some relief, because the fact that Python and Pandas are so explicit in their data analysis commands means that you should hopefully have a much easier time following exactly what happens step by step when we're merging these two datasets. Now, the very first step that we want to take is that we want to read in the second dataset, so the reader scores dataset. Right now, as it stands, we do not have a data frame that represents that data, so we want to create one. Now, to do it, we're going to do the exact same thing we did with the IMDb movie data. We're going to create a variable name, reader_scores, to store the data, and we're going to use the readCSV method of the Pandas module to read in the reader_scores.csv dataset. So now that it's in, we're going to go ahead and merge the two datasets. So I want to bring back the reader scores into my original movies dataset. So I'm going to basically store the result in my movies data frame, and to merge them, I'm going to use the merge method, which again is a method of the Pandas module. So the merge method takes the following inputs. The first thing we're going to pass is the original or the left data frame. If you happen to have worked with SQL before, if you're familiar with SQL at all, this is going to ring some bells because this is basically a join, right? The first input that we're going to give to the merge method here is going to be the first data frame that we want to merge. So in our case, it's going to be movies. That's our left data frame in SQL speak. The second input that we're going to give it is the right data frame. So the readers_scores, and that's basically the second data frame that we just created earlier. The next thing that we want to specify inside this merge method is the way we want to join these things. Now that we have both of our data frames together in the same place, we're going to try and merge them. To merge two data frames in Pandas is effectively to do a join. For those of you who are familiar with SQL, this is going to look very much like that. It's going to look like a SQL join. So I'm going to explain this merge method that we're using here to do this join in terms of SQL joins. So those of you who are familiar with joins can more easily follow. For those of you who are new at this, who are completely new at this and don't have experience with SQL, I'm also hoping that this is going to help you follow how the join works graphically. Now, because I want to add the reader_scores data frame to the original movies data frame, I'm actually going to rewrite the movies data frame. So I'm going to assign the result of this merge method to the original movies data frame. The merge method that I'm going to use here is actually a method of the Pandas module. So same as read_CSV here, we're going to apply this to the alias of the Pandas module that we assigned when we imported it, so pd.merge. Now this method takes in a number of inputs, and you'll see this over and over again when working with Pandas, that each and every method, each and every function that you use will take a number of inputs, and you can think of those inputs as knobs that you can turn in order to do certain things. Now, when you're doing a join in SQL, you are basically joining two tables. You can think of the left table as literally sitting on the left side of your screen and the right table as sitting on the right side of your screen. And basically what you're going to do is you're going to bring columns from the right table into the left table. So that's exactly what we want to do now. We want to bring columns from inside reader_scores into the movies data frame. So the movies data frame is going to be my left table, and it's going to be the first input that I pass to this merge method. The reader_scores is my right table, and it's going to be the second input that I pass to this merge method. And the next two things that I need to specify are going to be the type of join that I want to do. So just like in SQL, we have inner joins, outer joins, left outer, right outer. Here too, we can select from a number of different options. So in this case, because I want to bring a column from my right side table into my left hand side table, I'm going to do a left join. A left join is basically one that preserves everything in the left hand side table and simply brings in whatever information exists in the right table that corresponds to the existing rows in the left table and brings them over. So left table, right table, left join means that we keep the left table and we bring stuff in from the right table. Hopefully this makes sense. Finally, the last thing that we want to specify is the column on which we want to join. So that is basically the column which is going to serve as the common thread between these two data frames that we want to bring together. So in order to match up information from two data frames, we need to have a common point of reference, a column that exists in both, which we can use to match that information on. So in our case, the column we want to match on is the title column. One last point that I want to make here is the fact that in the spirit of Python explicitness, all the inputs are separated by commas. They're listed one after the other. The last two inputs, which we can actually change, for which we have different options, those options are passed to these keyword inputs as strings, right? So this is a Python string. Same for the on keyword argument here. On is, again, just the column that we want to join on or to merge on. And this can be any column that is common to both data sets, right? Here, we're just going to pass the column name that we want to use to merge on, again, as a Python string. Finally, let's run this. And here we go. So after we run the merge method on these two data frames, let's look at a preview of the new movies data frame, which should now contain the reader score. So let's scroll all the way to the end of this. And sure enough, there's an extra column here, and it's the reader score column. Finally, let's dive into one of the more complex operations that you will want to do when analyzing data, and that is pivoting data. So creating pivot tables. In our IMDb movie data set, we have a column that shows us how many runtime minutes each movie has. And of course, we have the release year, the year in which the movie was released. Let's say that we want to find out, on average, how many minutes a movie that was released in 2016 has, or how many average runtime minutes a movie that was released in any given year has. In order to do that, we're going to need to insert the pivot table so that we can average the runtime column for each of the years that we have in this dataset. So let's do that. First, we're going to select the entire dataset. Then we're going to navigate to the insert menu. In the insert menu, we're going to pick the pivot table option. We've already selected the table range because we want the entire table. And we're going to place the pivot table in a new worksheet. So there we go. We have a new sheet. Our old dataset is in here. The new sheet where we have the pivot table is here. So let's start picking the things that we want. First of all, we want the year. And we want the year to be a row label because we want to see an average number of runtime minutes per year. The next thing we want is the runtime for each movie. And we want this to be value in each of the rows. So we're going to drop that in the values rectangle here. Now you can see that by default, Excel is actually giving me a sum of runtime minutes. So I can see that I have more and more movies for these later years here, but I don't want the sum. Instead, what I want is an average. So I'm going to click on this I here, and instead of sum, I want to pick average. Click OK, and here it is. Average runtime minutes for each of the years. Now, moving on to our Jupyter notebook, let's create the same pivot table on the same dataset using Python and Pandas. There are actually several ways to create pivot tables in Pandas. There are different ways to pivot data and to group it, but today we're just going to talk about the pivot_table method of the Pandas module. Because this is a Pandas module method, it's going to work the same way as all of the previous methods that we've used so far in this tutorial. The first thing I want to do is create a new data frame where this new pivot table is going to live. So the output from this pivot table is going to live in the table variable. Then I'm going to apply the pivot_table method from the Pandas module. And this particular method takes, again, a number of inputs. You're hopefully going to recognize the inputs as the same inputs that we put into the pivot table in Excel, just in a more explicit fashion. The first thing we want to specify, of course, is the data. What data do we want to pivot? So the data is going to be the data frame that you want to pivot, in this case, movies. The index is going to be the index that I want in my pivot table. So one thing to mention here is that all of these inputs for the pivot table function are actually keyword inputs. So it doesn't matter what order you put them in, but you do need to specify the keyword input followed by this equal assignment sign so you can specify your exact input, right? So in my case, data equals movies because that's the data frame that I want to pivot. Index equals year because that is the first column that I want to have in my pivot table to serve as row labels for the data. The values, so the values that I want aggregated in my pivot table are those values in the runtime minutes column, right? Because those are the values that I want to average out. And finally, I'm going to need to specify the way I want to aggregate these runtime minutes. So the function that I want to use. If you remember when we went over the Excel example, Excel assumed that I wanted to sum up those minutes, but instead I wanted to use an average. So I had to go in and manually change the method of aggregation to an average. Here, I use the agfunc keyword argument, and I directly tell Pandas that I want to use the mean function. So I want to do an average of those values. And that is it. You specify all these things, you run this code, and voila. Now table is my pivot table, which is what I just did in the previous cell. And this is what it looks like. If you were to compare this to the Excel one, you'll see that they're basically exactly the same. Get exactly the same number, exactly the same outcome. Now that we've seen a side-by-side comparison of the 7 most common tasks that you're going to do when analyzing data, and we've seen those tasks being done in both Microsoft Excel and a Jupyter notebook using Python and Pandas, let's look at a couple of things that you can only do in Pandas. The reason why there's so much buzz around Python and Pandas for data analysis is the fact that Pandas offers a lot of really nice, simple shorthand ways to do some pretty crazy stuff, some pretty complex data analysis tasks. So, other than the things that we've seen so far, we're going to look at 2 more data frame methods. So these are, keep in mind, data frame methods that you can use to get additional information about the data in your data frame. So these are bonus in addition to the things that we've looked at before. Let's see what they look like. The first thing that we're going to discuss is dataframe.describe. Dataframe.describe is a way to get statistical information about the data in your data frame using a single line of code. The second thing we're going to look at is dataframe.info, which is another way to get some more information about what data you have in that data frame by simply running a single method. So let's try the describe method first on our movies data frame. Now the describe method by default analyzes only those columns in the data frame which are numeric. So it's going to give us statistics about the numeric columns in our data frame. Specifically, it's going to show us the count of values in each column. It's going to show us the mean value, the standard deviation, the minimum, the maximum, and of course the important quartiles, the 25th percentile, the 50th percentile, the 75th percentile. If we want the output of the describe method to also include non-numeric data, what we need to do is to specify when we run the method that we want to include objects. Objects are basically every other data type that is non-numeric. If we run this, we can see that we also get information about the non-numeric columns in our data set. So the title, genre, description, director, and actors columns. So we get a count, we get a unique count, we get the top most value in each column, and we get the frequency, how many times that top value shows up. Movies.info is the next one-liner that I'm going to show you, the next and last one-liner. And movies.info is going to show us information about the specific data that we have in this data frame. The info method is going to show us some of the same information that the describe method showed us. So it's going to show us a count of the values that we have in each column. It's going to show us how many columns we have. We have 14 columns in total, how many entries we have in total, what type of index we have. So in our case, we have an int64 index. So it's a numeric index that spans from 0 to 1001. It's going to tell us in a nutshell what data types we have in this data frame. So in our case, we have 4 columns which are float64. We have 5 columns which are int64 and 5 columns which are non-numeric. Pandas calls them objects, and it's even going to show us how much memory storing this data frame takes up. So that's it. Those were the 2 extra one-liners that you can use with your data sets moving forward to get some really quick information about them. All right, that's it for today. If you like this video, go ahead and subscribe to our channel and hit that notification button while you're at it too, so you don't miss any of the new videos that are coming up soon. If you want even more in-depth tutorials on Python and the latest AI technologies, feel free to check our blog at edlitera.com/blog, and that link is also going to be included in the description. All right, thanks for watching, and I'll see you next time.